Hello guys, hope all of you are doing great. In this part of the video, we'll be learning how we can read a number from the keyboard in 8086. When I say number, basically we write here integer number, how to read an integer number, both positive as well as negative from the keyboard in 8086 programming. That is, we want to achieve something like this. Say for example, a prompt will come, enter a number, and here the user will type a number, say for example 56, and press enter. As soon as the user enters 56, then in the program there should be some register or variable there. This number, say for example AX register, there this number 56 should be stored as a number. So that is what we want to achieve in this part of the video. Okay, now you see here, whatever it is that I'm now saying, that thing is very much equivalent to this scanf function in C programming. If you know C programming, certainly most probably you know. And in that case, if you have to achieve this thing like enter a number and then the user will enter a number from the keyboard, that thing if you want to do, what you do is you write scanf %d address of a, assuming a is the variable where you want to store the number, and you are asking the user to enter an integer number. So in that case, what this function will do, it will accept an integer number from the keyboard and it will store it in this variable a. So more or less, that is the thing that we want to do in this part of the video. Now see here, there is no direct instruction that we can use to achieve this, scanf functionality, right? So what we know is we have only these two instructions we have that allows us to read a character from the keyboard, and whatever the red character it is, or whatever it is the character the user enters from the keyboard, it goes to AL register. So here you can store 01H in AH first, and then you can call this interrupt service routine, and that interrupt service routine will accept a number from the keyboard, like it will wait for the user to enter some key from the keyboard, and whatever the key the user presses from the keyboard, it will go to this AL register. That we know we have actually. And using this thing as the building block, using this block of code as the building block, what we want to do is we want to write a equivalent procedure or equivalent program which is equivalent to actually scanf function. We want to write a procedure or program which is equivalent to this scanf function. So that is what we want to achieve. Okay, now you see, although the problem is accepting a number, integer number from the keyboard, so what I'll be doing is I'll be solving the problem in two parts. That is, accepting the number from the keyboard, that problem, first we will do one step, and in that step what we will do is we will not write a program to accept a number. We want to achieve this thing first, that is accept a valid string that can be that converted to a number later on. Okay, and what I mean by a valid string, I mean it should follow this state diagram. So what I mean is, see here, there are three states here. Like one is the starting state, one is I'm writing these names, these are not very tight actually. Okay, just I'm giving them some names. Say this is your starting state, this is your digit state, and this is your done state. Now see, when you start the program, that is, or when you run the procedure, what it will do is it will wait for the user to enter some key from the keyboard. So for the first time, if the user enters a negative symbol, it should be accepted. That is, the user might want to enter, say for example, -96. So in that case, you see here, first time the user presses this minus. So if the user is at this beginning state, that is, if the user has not typed anything till that point, and if the user enters a minus, then also it should be accepted. Or if the user enters anything within the range of 0 to 9, that also should be accepted. And see here, as soon as the first character is read with a valid symbol, then it goes to this understate digit state there. Okay, now if instead of typing this valid set of characters, if the user types any other thing, then it will go to done state, and that is the end of the procedure. So till that point, whatever it is that user has entered, that will be returned as the entered number. Okay, now in the digit state, again you see here, once the first character is read, like once this is read, this could be -96 or this could be 100 also. If the user wants to enter 100, then as soon as the user writes 1, and that immediately, because 1 is among these valid characters, so immediately it will move from start state to digit state. Or if the user enters or presses minus, then also it will move from start state to digit state. And in this digit state, after that, see here, after entering this first character, maybe a number, maybe a digit, or maybe this minus symbol, the rest, all these rest of the characters must be within this range of 0 to 9. If the user goes on typing some digits, it will remain in that valid digit state. Okay, and as soon as the user presses say enter or any other character, it will go to done state. It means okay, the reading is done. So till that point, whatever the user has entered, it will be returned as the entered number. So you might be thinking, what happens at the beginning itself if the user press A? In that case, the entered number will be considered as a blank, blank number. Nothing is there, actually. Nothing has been, no valid string is entered. So if the user enters say only minus symbol and then A, in that case also only this minus symbol will be returned, so which is actually not a valid number. Later on we have to verify that. Suppose if the user enters say say for example say minus 1, 2 and x, so in that case the entered number will be considered as minus 12, because x is, like, see here, when the user enters minus 1, it will be in initially at start state. As soon as it sees minus, it will go to digit state, then 1 digit state, 2 digit state, x done state. So up to x means before typing x, whatever it was, that will be considered as the entered number. So our logic should be driven by, or our logic will be driven by this state diagram. And if you have understood this state diagram, then the next thing is only writing the code in a proper way. Okay, so ultimately what we want to do is write a procedure in 8086 that accepts a valid integer number in string format from the keyboard. So I just relax the problem up to some extent. That is, whatever we read, we'll be reading it in the form of characters, and we'll be at the same time building a string version of the entered number. Okay, so you should realize this point, that if here, say for example in this case minus 12 case, this minus 12 is not equal to, or this minus 1, 2 will not be equal to the number minus 12. Okay, so that part I will not do in this part of the video. I'll be doing it in the next part of the video. But before actually writing the code, again, let's see. So this is our problem, and then what is the requirement? Let's see what we want to achieve at the end. So we want, suppose we'll be considering, like, we have a string like this. We'll declare a string variable, and then bx will set to point to that string variable. Okay, and then we want to write actually this particular procedure today, okay, so read string number, or you can give it any name you want. So I'm just calling it say read string number. So ultimately we'll write this procedure. Suppose now we assume that this procedure is there, then what it will do is basically it will accept, and this procedure will be equivalent to this state diagram. See, at the end this procedure will store in the string this part, say for example minus 12. Okay, got it? I guess people got it. So this procedure will do the task, and then what we want is, after calling this function, if we now store bx to dx, that is, if we now make dx to point to that particular string, and then if we use this ah equal to 09 and int21h interrupt service routine, we know these 3 lines basically prints the string pointed by dx register on the screen. So in this case, it should print the entered number, whatever the number the user has entered, that thing should come on the screen. So suppose the user has entered minus 1 to x. In that case, the entered number should be displayed as minus 1 2. Got it? That is the the problem that we are trying to solve. I guess now if people have a clear picture about the thing that we are going to do now. Okay, but again, last one point, let me tell you here. See, we'll be doing, as I said, no, this number minus 1 2, that string version is not equal to the number minus 12. So in the next part of the video, we'll be writing another procedure. Let's call it a string to number. So to this the task of this procedure will be to convert the string minus 12 to sum to the equivalent number minus 12. Okay, now this minus 12, if it is in number format, then what we want to do is we want to store this, say, minus 12 to ax first, and then if we call this n, this pen procedure we already have written in our previous part. And this pen procedure we have written like so that it can display any number, any integer number, positive or negative, on the screen. So in the next part we'll be writing this procedure that will that will accept a string, or that will take a string as an input, and it will return, or it will give us the equivalent number. Okay, so this part we will do in the next part of the video. So in today's part, we will be writing the code for this particular procedure, and the logic will be driven by this state diagram, or this finite state automata diagram. Okay, then now let's begin. Now we are at Visual Studio Code Editor, and this is the basic skeleton of any 8086 program till now we have been writing, right? From here we'll do the rest of the coding. What is the the minimum thing that we want to do? We want to repeatedly read characters from the keyboard. Okay, so that is a minimum thing that we want to do. So let's first start with reading a character. So for reading a character, what we have to do is, or to read a character, we have to first store in AH register 01H, and then we have to call int21H, that interrupt service routine. So what it will do is basically it will read a character and it will store it. It will store it in AL register. So that's what it will do. Okay. What else then? See, if you look at this this state diagram, you can see that I have like two states to differentiate between the first position, reading at the first position, and reading at the rest of the positions. Okay, and also you can see that I have written down there SI equal to 0 and SI is greater than 0. Now see here, this SI, yeah, I mean the source index, but the thing is that this is, you can think it of like it is just a counter that tells us for which character or for which position we are reading the character. So you can represent that counter by anything. So here I am representing it by these SI registers. Okay, so if the value of the counter is 0, that is, you are reading the current character that the user is going to type from the keyboard, it will go to the 0th position. So in that case, certainly it is the first character. And for the first character, we have to take care of this minus symbol. Okay, like that is a valid character in the first if you are entering it at the beginning. So that part we have to take care of. So mainly what we're going to do is here, see, it means what we need a counter sort of that allows us to keep track of like which position we are reading, and I'll be using the source index register for that purpose. So I'm clearing first SI to 0, so that it is the counter. It is the counter for the current position. You can call it, it is the index for the current position or counter for the current position. Okay, this comment is just for your help, so you just please interpret it in a proper way. So XOR SI comma SI, done. Like SI is at the beginning 0, and then we read a character. Now what we want to do is, we know the character we read is in AL register, so we'll be doing a comparison now. Compare the read character with this minus symbol, and after that what? Like if it is a minus symbol, you see here, the minus symbol when the user enters, then it is valid only when the source index is equal to 0 or this counter is equal to 0. If the user enters minus somewhere here, then it is not a valid character. It means we also have to check now this particular counter, whether it is 0 or it is greater than 0. So if it is 0, then it is valid. So that way we will proceed. Okay, so if it is AL is, that is, if this AL is negative, then we want to do something. But if it is not negative, so jump on not equal, then let's jump to some other place. Let's, for the time being, let's give it a label, say L1. If it is not equal, we'll jump to a different place. But if it is equal to -1, that is, if it is equal to minus, then we'll be comparing again immediately that whether SI is equal to 0 or not. Okay, So if it is minus and SI is also equal to 0, in that case, see, SI is equal to 0 means we are reading it at the first place. So if it is 0, then it's a valid character. Actually, we have to store it in the string. But if it is not 0, see, if we enter minus at and SI is not equal to 0, it means it's an invalid state. So for that reason, first let's fix this part. If it is not equal, jump not equal, that is if SI is not equal to 0, then what we want to do is we want to, like, okay, done, say, reading. So it means, see here, at this place, if the user enters a negative symbol, then we are done. Actually, it is the done state. We want to go to that particular state. Okay, so jump not equal, done reading. So it is done. But if it is SI is the first symbol is negative, okay, and see here, if the first symbol is negative, this jump not equal should come here. Okay, if the first symbol is negative, and if it is not negative, then it will you know, throw us this control will go to somewhere else. But if it is negative, means if they are equal, then it will do this comparison. And if this comparison is false, then we know, like, we are done with the reading. But if it is not false, that is if it is jump not equal false, then it will not do a jump and it will proceed. Now what is this? So if it is not false, it means a red character is minus and then SI is also 0. In that case, what we have to do is we have to store the red character, that is AL, in the string pointed by BX, in this particular string, which will be pointed by BX. So let's write this thing first. Load the effective address of this string to BX register, str1. Okay, load the effective address of the string str1 to BX register. Okay, done. Now once it is done, so if it is not equal, then it will go somewhere else. It will compare with 0, and if it is not equal, it will do done reading. But if it is equal, both of them are true, in that case, what we want to do, we want to store at BX plus SI, that is the, you know, the first character, as the valid character, which is AL. Done. And after that, what we want to do, we read the character, we stored the character, then certainly we have to increase SI. And after increasing this SI, we have to read the next character. So we'll be writing, say, for example, jump read next character. Next character, and where this read next character should be, it should be here, move. That is, how do we read the next character? Again, we'll do the same thing. We'll first store 1 into this. We'll store 1 into this AH register. Then we'll read that character. Then again, we'll do a comparison. If it is not equal, then if it is equal to -1, then we'll do SI. See here, suppose the user already has entered. Now let's go to a different state. Suppose the user has entered minus. So in that case, it will be equal. So jump not equal will be false. So if it is minus, and obviously source index next time will not be 0 because we have increased it. So this thing must be false. So in that case, we'll go to done reading. So done reading will be writing. It's a different state, say. So before doing that done reading, let's see what happens if the user doesn't enter minus there. Okay. Now suppose the user entered first state is done. Say, for example, the user at the beginning pressed that minus key, so it went there. Now this thing, okay, like, okay, let's see first. So if it is this done, and then jump not equal is L1. If the user has entered now, suppose not minus symbol but something else. Okay, so now I'll be calling it, say, for example, process digit. There, whatever that something else is, so we want to call it a process digit, and then we will see whether that something else is a valid character or not a valid character. So what we'll be doing is we'll be again doing a comparison. We'll be comparing, like compare. Now we know that that is not minus, but it could be any other thing, right? So we'll be doing a comparison. Compare that AL character with 0. See here, what we want to do is it should be greater than 0. It should be greater than or equal to 0. The valid character means it should be greater than equal to 0, and it should be less than or equal to 9. That 0 and 9 means this character 0 and character 9. Huh? So that is the thing that we want to. It means if these two conditions, had it been a C program, we would have written something like this, right? So this is the same thing now we have to do in 8086. So we'll try to do this thing actually. We'll try to write the code which is equivalent to this thing actually. Okay, done. Now first we'll be doing compare AL with the ASCII code of 0. So if it is jump on, see here, when it is valid, when it is not valid. So if it is less than, so if it is not 0, if it is jump on less than, it is like JL means jump on less than. If AL is less than, strictly less than 0, then what we want to do, you see here, at any moment of time, no matter where you are, maybe you are at the beginning state or maybe you are at this other state, if you enter some invalid character, the else part, actually you are going to the done state. So here also, see, if the user jump on less than means we immediately know the entered character is not a digit, so we are done reading. So this thing actually, it's jump on less than, we are done reading. Okay, now suppose it is not less than, jump on less than, done reading, say, but suppose the user pressed say 1, so 1 is not less than 0, 1 will be compared with 0, and it is 1 is less than 0, it is a false thing, so this jump will not happen, and then it will continue. And when it continues, then checking only one bound is not enough. No, we have to check the upper bound also. Immediately we will do that. Compare AL now with the character 9, and this time if you find that it is greater than that, okay, so jump on greater than. Got it? So if it is beyond 9, it is greater than, strictly greater than 9, then also we are done. So we are actually done reading. Okay, done. Now if this is also not true, you see here, if it is AL and AL is not less than 0, then this thing will happen, and if AL is not greater than 9, then this thing will happen. If it is less than 0, immediately it would have gone to done reading, and if it is greater than 9, then also immediately it would have gone to done reading. But if both these two conditions are false, like it is not less than, it is not greater than, it is not less than 0, and it is not greater than 9, so it means it is somewhere in the range of 0 to 9, it means it's a valid character. And what we want to do with the valid characters, we'll be doing more or less the same thing here, like same thing that we did here actually. Okay, so here we'll be doing this, say move. So since we know now it's a valid character, so whatever it is SI, in that index we'll store the red character, whatever the user pressed from the keyboard, will increase SI, and then we'll jump to read the next character. We'll go back to read the next character. And I think now all the possible cases are handled. Now you see here, when we read the next character, we see if it is, suppose the user again, suppose the next character is, say, the third character we are reading, and the user presses plus symbol. So in that case, what will happen? It will compare this thing with minus. So jump on not equal, plus is not equal to minus. So it will immediately go to process digit, and there plus will be compared with 0. It could be less than 0, or either it is less than 0 or it is greater than 9. Okay, so suppose it is less than 0, then also it will go to done reading. Suppose it is not less than 0, it is greater than 0, in that case we will compare it with 9. So certainly it must be greater than 9, so in that case also it will go to done reading. And that way we have to now write what we want to do in done reading. Okay, so in done reading, basically we are done. We are like we are done with accepting character. Only thing is that we have to put the terminating symbol at the end of the constructed string. So what we'll be doing is we'll be like putting the terminating character at the end. So when we done reading, basically we mean that, okay, first we will store explicitly this dollar symbol at the end of in AL register, and then that AL register, the content of that AL register will put at the end of the string, or at the position which is pointed by BX. You see here, every time we insert a character in the string, we are increasing SI. So at any moment of time, SI will be pointing to the blank spot, the next blank spot where the character should go. Okay, so that's all. Like, and then after that, if we want, we might want to display now the string. Say for example, now display the string. And where the string is now pointed by bx. But if you want to display it, then first thing that we have to do is we have to get that starting address to dx register, and that is whatever now bx is pointing to, dx will also point to the same thing, and then we'll store in ah09h, and then we'll call this int21h. Done. It will print the whatever it is, the string that the user has entered. Okay, now you can, now I think if I have written everything right, then this program should work. But if it doesn't work, then I'll come back here and I'll see where is the problem. Okay, I'll try to find out the problem. So now let's see the output of the program. Okay, so for that reason, okay, we are at TASM. So first compile the program. The program name is ytp18.asm. There is luckily no warning, no error. So link the link ytp18, that's all. And then we're ready. ytp18, we can execute. This program is waiting for me to enter something from the keyboard. So for example, I write 21 and I press enter. So it is okay. When I press enter, it is working actually. So I have entered 21. So 21 is being displayed there. Let's say I enter -93. So minus, it is accepted, 9 accepted, 3 accepted. And then suppose I press A. See here, 1, 2, 3. A. As soon as I press A, see, although I entered -93A, the entered string is considered as -93. Say I enter now two strings, two minus consecutively. Say first minus, it is accepted. As soon as I enter the second minus, it will be considered as it should be considered as an invalid character. So the process should terminate there itself. So as soon as I enter the second minus, it is terminated. But the constructed string is now with the first minus symbol. So you can see that minus symbol is coming here. Okay, so I think the program is working actually. So I can enter any number, say 1098. At this point, if I try to write any other character, say plus or minus, then immediately it will be terminated. So the entered number should be 1098. See, this minus is like I entered, so it is considered as the terminating character. And previously, whatever it is that I have entered, it is the actual number. The program will consider that part as the the entered number. Okay, then that is the program. Then let me do a scrolling here. So what we did is, this is our basic skeleton. We started with the skeleton. We are using this SI to keep track of the indexes, like where we are reading the character. And then we are reading a character first. So we read the character, we compare it with minus symbol. If it is not equal to minus symbol, it means it could be a valid digit. There is a chance that it is a valid digit. Okay, so we'll go to this valid digit thing, and there we'll be comparing whether it is less than 0 or greater than 9. If it is less than 0, then also it is invalid. If it is greater than 9, then also invalid. So in both these cases, less than 0 and greater than 9, they are like invalid thing. So the process is completed. But if it is not, like if it is in between somewhere, then we'll consider that entered character as a valid character, and I will store that character in SI index. Wherever that SI is, there we'll store the character, and immediately we'll increase the SI and we'll go to read the next character. Now see, this minus symbol is special, because if the user enters minus, then we directly will not reject it. Before rejecting it, what we'll do is we'll check if we are reading for the 0th position or not. If it is, then we will accept it. See here, if it is okay, then we'll accept it as a valid character, and immediately we'll go to read the next character. But if it is not in the 0th position, you see here, if SI is not 0, jump on not equal, then it is same as the number, the entered character is either less than 0 or greater than 9 part. That is, we are done with this done reading thing. So you should realize this point. So that is more or less is the main logic of the thing, and done. Now what we want to do is like, okay, although the program is right, I mean, although we have written the program, but we want to make it reusable, say, okay, like we might want to use the same code. Like suppose now we want to accept 5 numbers at many different places, or at 5 different places in the in our main program or something like that. So the good idea is that we put it inside a procedure. We make it as a separate procedure. Let's see how to do that. It's simple, huh? There is no special thing you have to do. So what you have to do is basically you have to declare this part as a procedure. I mean, this is the code, isn't it? So this load the effective address load the effective address. Or is the delete key? I'm sorry. So we want to write these load these effective address instruction at the beginning. So I'm just shifting position there, and I want to keep that thing outside the procedure, and this part below that part, whatever we are doing, I want to call them, I want to put that thing inside the procedure. So how to write a procedure? Say for example, accept string, say string number. That is the name of our procedure, say, and then that we want to write as a procedure. So I'm writing here accept string number is the name of the procedure, and procedure is the assembler directive, and at the end where it ends, so done reading, we mark the end, and suppose displaying the entered number itself inside the procedure, or let's put it outside actually, or let's for the time being put it inside. Actually we don't need it here. Okay, so what we do is basically we will delete it, and here we'll write this return statement, and then it is we want to terminate the procedure there. It's a long name, so let me copy it, and here I'm pasting it, and this is the end p. So whatever the code we wrote initially, now I put all the code inside this accept string number procedure. Okay, now you see only defining the procedure is not enough. We have to call the procedure. Let's check that thing. So first what we'll do is we'll make bx register. The procedure will always assume that bx is pointing to the string where it will store the entered number. So that, for that reason, if we want to store it in a different string, then we will like make bx to point to a different string. So for that reason, I kept this line outside the procedure. Okay, and then what we want to do is we want to call this particular procedure. That's all. And after that, we do not want a free fall to happen, so we want to jump to terminate program. Okay, now see here, call accept string number will actually call this procedure, and what this procedure will do is it will construct a string which will be pointed by, or which is pointed by, this bx register. So this procedure, see, we have removed, or we deleted, see, the procedure ends only with the construction of the string. It doesn't display the string on screen. So for that reason, what we'll do is we will explicitly try to display that. See, before terminating the program, we call this, and we know that the string is now in bx, so we will do this this extra manual work to display the string. So move bx to dx. Now we'll be storing move ah to 09. To ah will store 09h, and then we'll call int 21h. If everything is right, then this program should behave exactly the same way previously it was behaving. Okay, the output will not change. Only thing is that we just change the internal arrangement of the program. Okay, done. Now let's try to compile and execute this program. So task sum this. Okay, that's a good news. Now sealing this, and then we are executing it, and I'm entering 65, pressing enter. So 65, again run it, say -90, enter, -90, then again run it, say minus, so everything seems good now. So we have this accept number procedure ready, and before proceeding further, you see here the next step we want to do is, for that we know, like, so that we do not change accidentally the content of a content of a register which is actually used by some other which is used in a meaningful way at some other part of the code. So what is the like safety measure we have to take? So whatever the registers that we are changing inside that procedure, we want to keep a backup of those registers at the beginning, and once we do all the thing once we're done with those things, that whatever it is that we wanted to do, and at the end we'll like restore the backup register. So that's what we'll do. Now see first, what are the registers we are changing inside this accept string number procedure? Si, we are changing Si, you are changing Ax, AH means AX, you can consider. We are changing BX, we are changing AX, BX, SI, and that's all. Only AX and BX and SI register we are changing. So let's put them into this stack first. So push AX register in any order. You can do in any order. Okay, so push AX, then push BX, and then push SI register. Okay, so these three registers we are changing inside it, so we have pushed them into the stack. And when we are done with our code, like done reading and before returning, what we'll be doing is we'll be popping them out. But when you do pop, you have to do it exactly in the reverse order. So whatever you pushed at the end, you will pop at the beginning. So pop Si, pop, see, pop will always return you the topmost content, the topmost word of the stack. But where we want to store it, we want to store it in SI register. It is something like that. Okay, pop the next word from the stack and store it in BX register. Pop the next word from the stack and store it in AX register. That's the meaning actually. And we don't need this pushes that. And then now our code is ready, and we have taken that safety measure also, like so that we don't change anything accidentally. Everything is done. Now what we can do is now we can make use of this code. But before actually proceeding further, it's a good idea that since we changed something in the code, it's a good idea that we just check whether it is still working there or not. Okay, so that error doesn't accumulate. Otherwise it will be very difficult. 89, say 98 is done, so minus 90. Okay, so okay, that's good. And say I want to do minus 90 and minus 90. Say for the time being it is working actually. Now suppose we are like sort of done, right? Like before proceeding further, let me scroll down a bit, and let me show you the code, so that if you are like typing but you are not exactly doing it, so you can pause the video for a moment and you can type it. We are still yet to go for another 2-3 minutes. Okay, okay, so that is our program right now. So this program, what it is doing is, see here, this part here, this is the procedure, but we are calling the procedure only once here, and then we are displaying the string whatever it is entered. These 3 lines displays the entered number on the screen, and then we terminate the program. Now suppose you just consider that we have an array, and no need to consider as an array. Now you just consider that we have to accept 5 numbers, 5 numbers in string format. Okay, so we have an array and we want to fill the array. That part we'll see in the next part of the video, but just consider that we have to accept 5 numbers there. Okay, so a string version of numbers. Then how we can do that? So we just can put this, or we can call this accept string number in we can put it in a loop, and then we are done, right? So let's do that final step. So for example, we store load the effective address in string 1. That part we'll do, and we can do it only once. That is okay, fine. And then what we'll be doing is, so move cx comma how many times we want to, like how many times, say. Okay, so say 5 times, or maybe 3 times will be good. 3 times, say. Okay, and then we want to put it inside a loop, so just call it like read next number, and it will call accept number. It will display the number on the screen, and after that it will loop back to read next number. So we are putting now this function call or this procedure call inside a loop. So this since we are using loop instruction, it will go as many times as the value of the CX register. So 3 times means 3 times everything will be repeated, and that way it will accept 3 numbers from the keyboard. So let's see. Let's compile the program and re-execute it. Okay, the first number, say 12, enter. 12 is displayed. Now it is waiting there since we have not displayed any prompt, so it is, we don't know exactly what. But suppose since we are writing the code, we know. Now next again I have to enter another number, 23. Suppose I'm entering and pressing enter, so 23 is displayed. So again I'm entering, say 564, pressing enter, it displays me 564, and then the program is terminated because 3 numbers, we wrote the code like, you know, the loop was for 3 numbers. So if you want to accept more numbers, then we can increase this value, and that way you can, you know, accept more numbers. So this program was good, but the thing is that prompt was somewhat, you know, clearly missing, no? Like we wanted to display a prompt. Say for that reason, you just declare a prompt variable db, and then prompt should always come to the next line first. So I'll be writing 10 comma and then enter a number. Okay, and the user will enter. The user will usually press enter as the terminator, and immediately the number will be displayed. Okay, so every time we call this except this, you know, what we want to do is we want to display a string. Actually, before calling that function, we want to display a string, and this is the code for displaying a string. And what string we want to display? And the load the effective address of some string that we want to display to the X register, and this time the string is this prompt string. Okay, the string whose name is prompt. So done. I guess it will now work. It will be more clear now. Output will be more clear. So this, okay, now it's showing me junk because I wrote here enter a number, but I didn't terminate the string. I'm sorry for that. Again, you were knowing it from the beginning, no? You saw my future. This is a mistake. Now I have to restart. Just a second. Okay, we're back. So TASM and YouTube program 18.asm. Okay, the link YouTube program 18 and YouTube program 18. So enter a number, say 21. Now it looks better, no? Enter on the number, say 54. Enter a number, say 908. So these 3 numbers I have entered. Okay guys, then we wrote the program, but you should know that we are done only up to this point. That is, we wrote a procedure that can read a string, a valid string sort of, that can be converted to a number. Okay, now the next part of the video, in the next part of the video, we'll be writing this specific procedure that will assume that, okay, there is a string pointed by BX register, and it will try to convert that string to its equivalent number. Okay, that's all then. Okay guys, then hope you people have enjoyed the video, and if you like the video, please press the like button and subscribe the channel. It will help me grow my channel. See you guys with some new content, that is with this content, in the next part of the video. Till then, have a nice day.